Hello guys, welcome to today's session. We'll be going through the 2022 past paper, the exam. So let's go through it. So I think in this session I'll just answer question one. Yeah, I think question one should suffice. Yeah, just question one. Yeah, we'll just do question one. So we're gonna start with the UML. So yeah, let's draw the diagram. So let me open DIA. So while the DIA is opening, okay. So let's read the question. So use UML to model the following scenario. A musical instrument has a textual name, starting note represented as a character, and a color represented as a record structure of red, green, and blue pixels. A musical instrument can generate a note, but the way this mechanism takes place depends on the kind of musical instrument. So that means we have different kinds of musical instruments. So the first musical instrument, or the first type of a musical instrument that we have, is a digital instrument, which is a musical instrument that overrides the mechanism for generating a note. And then there's also a keyboard, which is a digital instrument and can perform an additional operation of combining sounds while also being able to override the digital instrument's mechanism of generating a note. Okay, so we have a keyboard is a digital instrument. So the keywords you need to look at is this. For example, is a, which basically means that it's inheritance. So we have a base class and a child class. Basically, for example, um, why do we conclude that is a is thing it's inheritance? It's because if you have the class fruit like this, and then you have the class apple, which inherits from fruit. We call this inheritance because apple is a what? Fruit. So apple is a fruit. So, but basically that means is that we have to have inheritance. We have a parent and a child who is born, and a child who is the parent of base class. So every fruit is it inherits from the fruit class as long as it's some type of fruit. So we can have apple, we can have banana, we can have any type of fruit. But just know when you see is a, where that denotes inheritance. And then when you see has a, so with inheritance, we usually call this an is a relationship. So basically is apple a fruit? It's an is a relationship, so it's inheritance. And then we have has a relationship, which could denote composition or aggregation. So what's the difference between the two? So with composition, the contained class or object, you can say contained class or object cannot exist without that class that it is contained in. So basically what this means, if I have a class, if I have an object or a class within another class, all I'm saying is that in composition, if that class is within that class or that object is within that class, it it only exists because that class that class that of which it is inside of exists. Without that existence of that class, then this class wouldn't exist too. What do I mean by that? You can imagine a car has a engine. So what I'm saying is that remember this engine is like a class within this class. So engine, this class cannot exist without the existence of car. Why would you make an engine and then not use it? Because the engine only works inside the car. So that's composition. The contain class, which is this one, engine, in our case, cannot exist without the class that is in that it is inside of. It cannot exist if that class that is inside of doesn't also exist. So if car stops existing, then there's no need for us to make engines because engines power up cars or engines make the car work or the car function. So in order for the engine to exist, there must be a car first. So there's a life cycle dependency here. This is what we call life cycle dependency. That's a life cycle dependency. Then we have aggregation. So basically it's the same thing. It's that contain class. Basically that class within that class, it can exist without the existence, can exist without that class. So it can exist without the existence of that class that it is inside of. So you can imagine if the engine could exist even if a car didn't exist. You can imagine it like that. So let me see, what relationship can I denote? Um, okay, yeah. I can make a simple example. I can say a bottle has water, right? So water does not need to exist. Bottle does not need to exist first in order for us to have water. So water can exist independently independently of the existence of this class. So you don't need the bottle to exist in order to have water. The water is always there. They're two separate entities. As you can see, they're just two separate things. But then we happen to combine them to formulate one thing. So just keep that in mind. Those are the two different um, um, hazard relationships, or we call them containment. It's the containment topic, and there's two different types of containment. There's composition and aggregation. So, like I said, a bottle has water. Water can exist without the existence of bottle. So we don't need the bottle to exist first in order for us to say, okay, there's a need for water, so water needs to exist. So yeah, just keep that in mind. And yeah, you can have as many examples as you want. For example, a person has a heart. So the heart only exists because the person exists. The person needs the heart to function. So therefore, this is composition. This this heart cannot exist without the existence of person. But then when you look at here, water can exist without the existence of a bottle. We have river dams. There's water there. You don't need the bottle to exist in order for water to exist. So just know the difference between the two. And then when it comes to aggregation, right? Remember here we say there's life cycle dependence. Why am I saying life cycle dependence? So what basically that means is that the person who has that class or that object, he's now responsible for managing that object. For example, a person has a heart. a person is the one who's responsible for managing the heart. The heart is no longer responsible for managing itself. So if you don't eat a healthy diet, obviously it's going to affect your heart. So you are responsible for managing its life cycle up until it's no longer in existence, up until it stops beating. So you can't be eating junk food, eating lots of foods with food with a lot of oil, all of that, because that's going to affect the heart, because there's a life cycle dependence. You are in charge of taking care of this heart. But then when it comes to things like water and the bottle, you're not in charge. You don't have to. Water takes care of itself. Yeah, water is an independent thing. It's just that it's being contained within a bottle. That's all there is to it. There's no managing its life cycle. There's no making sure that the pH of the water is of the right level. All of those things. The bottle doesn't do all of that. It doesn't make sure the pH water is good. Water doesn't do anything. It's just there to contain the water. That's all there is to it. So just know those two differences. And when I say life cycle dependency, right, for this one, it means that, for example, when they say the class manages the life cycle of, yeah, whenever they say this, that means that with composition, whenever they say the class manages the life cycle, it means that it's composition. And then since it's composition, that means we're going to create, for example, let's say the engine class, the engine object, and make a pointer there, and then call it underscore engine. So we are putting a pointer here so that we can manage its life cycle, so that we can be able to say underscore engine is equals to new, right? And then after, remember, every new is accompanied by a delete, so that we can also delete underscore engine. So this is managing its life cycle. When they say it manages life cycle, just know it's composition, and you have to put a pointer for the object that's inside of that class, and you have to instantiate it and delete it. When it comes to this one, the aggregation, there is no life cycle dependency. So bottle, the class that has that object, it's not responsible for taking care of that object. So that means I can just have water like this, underscore water. And notice there's no pointer here because I'm not managing its life cycle. This is just aggregation. There's no life cycle management. I don't have to manage and maintain that the water is of the right temperature and all of those things. I don't have to do any of those things. Water manages itself. So yeah, just keep that in mind. Those are the two different things. So as you can see here, we have is A. So which denotes what? Inheritance. So we have a base class and child classes. So basically I have a parent and children. And then is a digital whatnot, can perform additional, must be able. A musician maintains a collection of musical instruments and can add or remove musical instruments from the collection. The musician does not maintain. Yeah, you see, it's very, very important what I was telling you guys. The, the musician does not maintain its life cycle, does not maintain. It's something that's gonna make you lose a lot of marks because this is 5 marks. If you don't write everything correctly, if you put a pointer when you're not supposed to put a pointer, you will lose marks. You see, here the musician doesn't manage. Here is what? It's aggregation. There's no management of the life cycle, or there's no maintenance of the life cycle. When they say not life cycle, that means it's the opposite of life cycle, right? That means there's no pointer. But if they did say it does maintain or manage the life cycle, then you know it's composition. I'll have to have I would have to make it a pointer because I want to have the new keyword and I also want to have the delete keyword. So let's do that now. let's start with musical instrument. And remember the way you name your classes, right? You must use what is it called? That case. What is it called? There's a name for it, but yeah, all I can think of right now is camel case. The camel case is basically, for example, the first word is written with a lower letter. So I can say maybe that's the first word, right? As you can see, the first letter is in small letters, and then the next word, no, the first word, the f- the f- the first letter of the first word is in a lowercase, and then every word, every subsequent or every word that comes after it is going to be capitalized. So I can say, for example, my name is this. As you can see, I start with the first word, the first letter of the first word did no capital. But then every word after it, for example, name, this is a word. So I capitalize its first letter. And then the next word is, capitalize the first letter. The next word is this, I capitalize the first letter. So this is how, this is how you should name your variables. This is one of the ways of naming your variables. Or you can just use small letters everywhere, but then separate each word with by an underscore. So my name is this, right? So this is a different way, but this second way of using underscores is the one that's commonly used. Yeah, because I think even Google's let me check. Even Google's what is this? Um guide on C++, naming things in C++, it has that. So let's see. Google.github. Let's see. Yeah, the style guide. I mean, yeah, it's called the style guide. Okay, this. Let me use the Microsoft one. Microsoft C++ style guide. Okay, there's the style guide. Um, coding style guides. Okay, let's not go into the coding style guides too much, but when it comes to naming classes, right? Just know, yeah, you see, just know that it's gonna be like this. So I forgot what it's called, but yeah, it's a, it's a, it's a, it's a what? There's a word for it, but I forgot. But yeah, when you name your class, you should start the first word, the first letter of the first word with a capital. So for example, let's say my class is Apple, what is this? Circle shape. Let's say it's called circle shape, right? So the first word is gonna be capitalized. The first letter of the first word is gonna be capitalized. So circle, that C is gonna be capital. And then the next word after it is gonna be a capital. So basically capitalize the first letter of each word with no spaces in between. You see, I don't have spaces in between. Don't make that mistake because the computer is very literal. Imagine now you have to instantiate this class or create an object of this class. How would you create it? You're gonna say circle, right? And then you put a space like this, and then you say shape. Then you say obj shape, right? So the way it's gonna interpret it, it's gonna read it as it's gonna be so confused. It's gonna be like, okay, so does this mean this is the start and then this is the end, or this is where it starts and then this is where it ends? But I don't know. There's no shape class. There's also no circle class. So it's gonna complain. It's like in our language, language that we use, our native language or English, whatever language that you've used, you know that there's punctuation marks. So imagine if I said I am going to school. I am going to school, right? And then the other sentence is I am the best gamer, something like this. You see what the problem is? There's no comma, there's no nothing. I don't know where the sentence, where does it start, where does it end? Okay, I can tell where it starts. That's at I, but is this one sentence or is it two different sentences? And I don't know where to start. Maybe the sentence could start from here, or it could stop at here. It could stop at I. This could be the first sentence. So yeah, I see that becomes a problem now. So in C++, you have to be, or in any programming language, you have no spaces in the class name for the class name. So like this, so that it knows, oh, this is one thing. So that now when you create the object, inside your main, like this, right? It knows, oh, circle shape. And then it looks for it, it's like, oh, there it is, circle shape, object, done. Just like here, I can put a full stop here and then put another full stop there. Then the educator is gonna know where the sentence starts and where it stops. It stops here at this full stop. And this is a new different sentence. So yeah, this is very important. So even though it's called musical instrument, the class is called musical instrument. Don't put the space. Don't put the space in between the name. Combine it into one thing. So if you want to create the class, right? But you guys are not gonna use dear. You're gonna be writing on a piece of paper. But yeah, you just click this and then change it to UML because you're doing UML diagrams. And then you look for the class. This is the class icon. This is for when the class is generic. You use this one if the class is generic. But then our class, there's no generic classes, so we're just gonna have this. So you just drag and drop. You can just drag and drop like this, or you can click and then click here again. That's how you can drag and drop it to create a class. And then you double click that thing that you drag and drop. And then for the class name, it means what's the name of the class. So basically it means you're gonna say class what? This part. This is the part they want. What is the class going to be called? So it's gonna be called musical instrument. You see, no spaces in between. And the first letter of the first word is capitalized. And the letter that comes after the word that comes after it, its first letter is capitalized. Just that L is a bit weird. Let me see. Musical. Ah, yeah, I and L. This looks very similar, but yeah, trust me. This I didn't. I'm following I'm following the rules here. So it has a textual name. So textual meaning that it's text. And if you remember text is just a string of characters. That's text. It's a string of characters. So it's a string of characters. It's called name. It's the name. So under attributes, so we have attributes and then we have operations. Operations is functions, it's methods. Attributes, it's variables, it's data. So I'm gonna click new to add the variable name. So under name, what's the name of that variable? That's basically what they're saying. I'm gonna use underscore name. And then what's the type? It's going to be of type string. And remember, all data types in C++ are in small letters. So just keep that in mind. And then value, this is like a default value. What do you want the default value to be? You could put it there, but now we're not going to do that because that's not part of the requirements. And then obviously all attributes need to be kept private. Then you create accessors if you want the user to have access to them, or you create mutators if you want the user to mutate or change the variable. So by default, it must always be private. And then when you make it private, you're gonna see that negative symbol there. So let's also talk about the symbols. So if you want to denote something is private, you put a minus. So this means it's private. If you want to denote something is public, you put a plus. If you want to denote something is protected, you put a hash. It's protected. This is only the things that you need to know. Only this. The UML question is not that hard. It's just 5 marks. So don't try to be fancy and try to explore more things. They won't make it that difficult. So we have the textual name. And then you could create accessors and getters. It's not necessarily important, but you could, because they didn't ask you to do it. But yeah, we'll see if the user has to access, or the other classes that we're going to create have to access the textual name, then we're going to create an accessor for it, because the user needs to be able to access the name. So that's the starting note as a character. Wait. Oh, that's the starting note. Oh, it's a note. It's just a note. Yeah, and they said the character. Yeah, it's a singular. It's not characters. So since it's just a character, it's just one character. So I'm gonna use char. Then apply. They just, yeah, I didn't see that. But yeah, just make sure you read carefully. It's a character, not characters. If they said characters, then I would know, okay, this is a string. It's a string of characters. But here it's only one character, it's just one letter. So it's just going to be char. And then a color represented as the record structure of red, green, and blue pixels. So it's a color. You can, I don't, they don't really care whether you have to show the record structure or not, but just use type. Like like use a proper name. Like you, it has to make sense. So for example, I have to create a color, right? So what's going to be its name is going to be pixel because we are representing pixels, right? So I'm going to call it pixel underscore pixels or pixel. It's just a pixel. They didn't say a color. Yeah, they didn't say an array. Yeah. So it's just a pixel, not pixels. And then what's the data type? The data type, they don't care. Just make sure the data type makes sense. We called it color, or for some people, they like to use the reg at the end to denote that this is a record structure. You could write it like that. Still fine. So I'm gonna call it color and then obviously private, because that's how everything should be in a class. Every data for the class should be private. And then a musical instrument can generate, you see, they're using what? A verb, generation. It's an act. It's a doing word. So you're doing something. So remember what I said in our previous lessons. When you see a noun, this is data or a variable in simple terms. And then if you see a verb, and then remember what a verb is, a doing word. Basically, it represents action, that you're actively doing something. This is This you represent methods or sometimes we call them functions. So just know that. If you look at the scenario, it says can generate. Generate is a verb. So I know for a fact this is a function. And by the way, this mechanism takes place depends on the kind of. So they said it depends on the kind of, meaning that it's going to be virtual. It depends on the kind of instrument. And we typically don't want to make it just virtual, want to make it a pure virtual. So that means I have to make the thing virtual. So if you want to be like 100%, okay, you don't have to denote, you don't have to, when you're writing the design, you don't have to write like virtual inside the design. They can tell by they can just tell by you defining the method in the base class and in the child classes, which means that it's going to be a virtual function. They can tell. But then when it comes to doing diagrams, you can specify, you can put those keywords. So remember that now we are supposed to make a generate node, and they didn't say it should return anything. They just said it should generate. So it's a void. If they didn't tell you about generating and all those things, just assume it's a void. If they didn't tell you the return type, what should it return? They didn't talk about any return, then yeah, you should know it's a void. So the name is gonna be called gen node for generating a node, or you can just write it in full. Generate node. Yeah, it's not really a long name, so just call it generate node. And then the type, remember, we don't know what the type should be because the return type, they didn't tell us what should return. So we're just gonna say it's a void because it just generates a node. They didn't say calculate and return the answer, or calculate and return the sum, something like that. They didn't say that. So obvious is gonna be public. And then inheritance type, you see polymorphic. With the diagram, it's gonna make it slightly italic. If you check after doing this, you're gonna see virtual functions are slightly italic. So yeah, I'm gonna choose polymorphic or virtual because it's a virtual function. And then yeah, I don't have to, yeah, I don't try and don't try to mimic what you've seen in the code. For example, it's called generate node, right? Some people are gonna be like, okay, where's the equals to 0? Don't worry about that. It's just a design. A programmer, remember you're writing this design for another programmer to use, so they know what, trust me, they know what virtual is. And the people who are going to be marking your papers is people who are computer scientists. So they know, don't try to find a way to put is equals to 0 here. It's fine like this. As long as you redeclare it inside the child classes, they can tell, oh, it's a virtual function. So we are done creating the generate node. And they didn't talk about all these things. We didn't talk about a lot of things and whatnot. So you see, that's fine. We are done. We're basically done with musical instrument. We are literally done with it. As for the other things like constructors and what, you don't necessarily have to put them because they didn't say you should initialize, should have a constructor. You're just answering the question. And as you can see, it's only 5 marks. Don't waste time on 5 marks trying to show them that, okay, you know the stuff. Don't waste that time. If you are indeed a person who writes fast, remember that this 5 marks means you should spend 5 minutes to answer this question. Not more, no less. It's a maximum of 5 minutes to answer this question. That's what 5 marks means. Especially if since this test is going to be out of 100, that means each question or each mark is equivalent to 1 minute. Don't spend more than 5 minutes just doing the UML. Don't do that. Make sure, I mean, you can tell when 5 minutes of this has passed. Make sure that you don't spend more than 5 minutes because, yeah, it's gonna affect you. Or you could maybe spend at least like 8 minutes or 10. And then for the other ones, if you just know them by heart, those ones you just go through all of them one by one. So yeah, we don't have to worry about constructors and whatnot. Don't complicate it. That's not what they asked. They just said, can you generate? So they need to see a generate. You could, okay, you could technically create accessors and setters. Let's check, let's understand the child classes first, to, before we decide whether we need to have accessors or getters. So a digital instrument is a musical, you see, is a. So it's a type of a musical instrument. So there's inheritance there. That overrides the mechanism for generating a note. So it overrides this generate node function. And remember when you have it, okay, when you have let me see. Yeah, okay, we don't have to worry about a lot of things here. We can I'm just trying to think about how this digital instrument will be able to generate the note without having access to UJ. So yeah, I forgot to add that no, not UJ image, man, musical instrument. So we need to pass a musical instrument by reference here. So just that on the diagram is a bit weird, but when you write it down, it won't be that complicated. Yeah, when you want to pass parameters, you go to the parameters section here, and then you give it a name. I'm passing a musical instrument by reference. And remember that it's supposed to change, right? So it's supposed to override and generate a note. So it's supposed to change the musical instrument. So I need to pass it by address. And then, okay, no, that's the name. So the type comes here. So the name, I'm gonna call it obj instrument, like this, and then apply. So now this is fine. This is now 100% correct because we have a way to access the musical instrument and make the changes. Because if you don't pass the musical instrument by reference, we won't be able to change it. So we need to pass an object. Because remember what it says. It says it overrides it overrides a musical instrument function called generate note to update or to generate the note for that specific object or for that specific musical instrument. So therefore, I need to pass in an object of type musical instrument so that I can change musical instrument. And then yeah, okay, so I think we should be fine now. Okay, so this is another key thing that you need to understand. So we are generating a what? A note. Okay, they won't really penalize you that much, but there's something else that we should be. Remember, I was talking about accessors and getters, right? So we need to check what are we updating. You see, as you can see, I'm updating what? The note. And where did they talk about the note? Has the textual name. That name represents the note, right? So that means I need to create a setter for name as a textual name, starting note represented as a character. Okay, let's not call it name. Let's call it note because now it's gonna become very confusing. Let's call it note because it represents the note, right? And remember, we need to set the note. So I need to create a mutator or a setter for it. What's gonna be the name of it? I'm gonna call it set. Remember that every setter is prefixed with the 3 letters SET, set in small letters. If you want to create a get, you'd start with 3 letters GET. But I want to set the note. So I'm going to set the note, call it set note because it's meant to set the note. And then void, and then it's going to take in a note, obviously, right? It needs to set the note. So what's the name that I'm going to take in? It's going to be a note. I'm going to call it just note. And then what's the type? It's of type char. Remember that my note is of type char. It's a character. Then there we go. I have the set note because they said it should generate a note. Obviously, when it's generating a note, that means it's setting it. So I need to be able to set it. And then a keyboard is a digital instrument and can perform an additional operation of combining sounds while also being able to override the digital instrument's mechanism for generating a note. So that means it's going to be still virtual inside digital instrument because as you can see, we are still overriding it. So that means the digital instrument will not implement it. It's going to continue again being a pure virtual function. It's going to continue being a pure virtual function. And then a musician maintains musical. Okay, generate a note. Yeah, they didn't talk anything about color, setting the color, getting the color. Yeah, they didn't talk about all of those things. So I don't need to create an accessor and the mutator for it, for the color. So this should be fine. You see, this amount of information should be perfectly fine. You don't have to add any extra things. If you feel like adding any extra things, wasting your time, you could. Nobody's gonna stop you, but just not wasting time. So I'm just gonna be that person who likes wasting time and start creating constructors, even though I was not asked to create them. So I'm gonna create a parameterless constructor, and I'm gonna create a parameterized one. So it takes in two things: the node of type char and the color. So name, I want to call it color. Then color. Remember, the data type of color must match with the one that you've declared. Yeah, they're gonna just assume there's a record structure called color. Yeah, there we go. You don't have to create constructors, guys. Don't waste time. But if you're very fast at writing, you can write them. So there's our class, musical instrument, right? It has the generate node there. So what I'm going to do, right? I'm going to take another class, click, then click the screen here to paste. And then now we're going to create digital instrument. So digital instrument is a musical instrument. So let's give it a name, digital instrument, right? And then let's add the operations. What does it supposed to, what is it supposed to do? Okay, this one doesn't have a lot of things. You see, it just only has the generate function. So a musical instrument that overrides the mechanism for generating a note. So basically what they're saying, just they're telling you just to redefine it, redeclare it inside this class again, so that they can tell, oh, this function is virtual. That's all they're saying in that question. So let me redefine it. Let me add, I'll go under operations because it's a function. So I'm gonna rename it exactly the same way it's named inside of my base class. Generate node, it returns a void, it has a parameter, it's called obj instrument, and then the data type or the type is gonna be musical instrument reference. Address of. So it's going to be taking the address of musical instrument. So as you can see, this is how basic this class is going to be. It's going to be like this. You see, then I'm going to have this, and then I'm going to use the inheritance. The inheritance is the, come on. This is the symbol for the inheritance. And make sure it's empty. You don't shade it in. You don't color it in. This triangle, don't try to color it in. Don't do that. It should be kept empty like that, or else you're gonna lose marks for the symbol. You're gonna lose marks because you need to show that this is indeed inheritance. So we have this class, right? Now we're done. We're done digital instrument. We're done. They didn't talk about, you should also have this. They didn't say any of those things. Just keep that in mind. We have keyboard, which is a digital instrument. So it's a type. So we have another inheritance. We're inheriting from digital instrument now. So I'm gonna go here, take this class, and then keyboard. And then remember, it's supposed to have these two operations. It's supposed to generate the node again. So generate node, and then void, and then it takes in obj instrument, and then the data type is musical instrument by reference. Apply, and then remember they said the shell should, besides just generating the node, it can also do more. So it can perform an additional operation of combining sounds. So it has an additional operation. Operation, it's a function. As you can see here, I'm adding the functions under what? Operations. So it can combine sounds. So the function is going to be the same. It's going to be a very simple name. Combine sounds. Simple. I don't have to worry about anything, and then it's void. They didn't talk about return types or anything. Just leave it like that. Combine sounds, void, done. Then move on to the next. It's supposed to also generate a node. We did repeat that. There's the generate node here. So basically, the keyboard class is the one that eventually ends up implementing that pure virtual function. And then we also have a musician. So I'm done with this one, with the keyboard. I'm done. So this inherits from digital instrument. So it's a type of a digital instrument. There we go. And then you get your marks, get your total here. A musician maintains a collection of musical instruments and can add or remove musical instruments from the collection. So yeah, you have a collection of, yeah, this is gonna be it's gonna be a bit tricky. Can add or remove musical instrument. So what I would suggest you use here, right? I suggest you use a vector, because with the vector, it resizes dynamically. So every time you add something, the size keeps increasing. If you remove something, it um not let me just say it's not dynamic, it's automatic. Let's just say automatically. It resizes automatically. So every time you add something, it increases the size by 1. Every time you delete something, it decreases the size by 1. So that's I feel like that's the only thing that you can write there. That was for you guys. So for now, that's the only thing you can use. But I think you can also use a list. There is a list in C++. You can use that too, but you are not taught lists. So I suggest you use a vector. And that vector is going to be, it's going to contain what? Musical instruments. Remember what a vector, a vector is. It's just a generic class like this. You can, remember you use these two symbols, and then we'd specify any type in between. So to create a vector of integers, we declare it like this. But then we want to create a vector of musical instrument. So the type that I'm going to pass here is going to be musical instrument, or instrument, the name of the class, the name of the type, which is the name of the class. Because remember, when you're creating a class, we are defining a new data type, our own data type. So I'm going to create this class. What should it be called? Musician. Musician. And then attributes, right? Remember, should have a vector. And then it maintains a collection of musical instruments and can add or remove musical instruments from the collection. So I would have to create an add function and a remove function, because you should be able to make changes to that vector. So what is going to be the name? I'm going to call it vec instruments. Or you can just don't complicate, just say underscore instruments. You know that it's instruments. You don't have to put that vec in there. And then you make a vector like this. That's the data type, a vector of musical instrument, like this. And then obviously it's private. Then we're gonna have to create an add function and a remove function. So void, okay, the name is gonna be add. We can call it add instrument or remove instrument, or you can just call it add and remove. Don't have to worry about many things. So obviously we need to be able to add into the vector, right? It's a vector of what type? Remember, if you're adding an integer, you'd say the type is int, but we're adding musical instruments. So the type of this parameter is going to be of type musical instrument. So basically it's going to be an object, obj instrument. It's going to be of type instrument. And then apply, and then I also need to be able to remove it. So the name is going to be called remove, return void, because all it does is just changes the vector. You don't return anything, you just change the vector. So I'm just going to use void there. And then the name, I'm going to call it obj instrument again. The type, it's of type musical instrument because the vector is a vector of musical instruments. If it was a vector of integers, then I'll be taking in integers here. So we have this vector of, and then should be able to add to remove instruments. And then that's it. Yeah, okay. This part, the musician does not maintain the life cycle of musical instruments. So that means it doesn't maintain the life cycle, right? So that it means doesn't manage, right? So what it means is that you're not going to have a vector of musical instrument pointers. It's just going to be a vector of musical instrument. If you're managing the life cycle, you'd have to put a pointer here like this, because I need to be able to say new. But since I'm not managing it, I'm not going to put a pointer there. It's just going to be musical instrument, just like that. Then apply and then okay. Yeah, for this class, for the class that is musical instrument, you don't have to worry about constructor and whatnot, because you can say, let me take in a default value, a default musical instrument. Yeah, you can do that. And either way, it's a waste of time. Your application is going to be very slow. Yeah, it's going to be, don't do that. So now how do we denote aggregation? So it has it has a vector of musical instruments. Yeah, it has a vector of music instruments. So the musical instruments are inside the musician class, right? So that means the diamond must point to musician from musical instrument. So musical instrument is part of this, like this. And it's part of this in terms of aggregation. So aggregation, you leave the diamond empty like this. If it's composition, you'd shade it, you'd color it inside. It would be black like that. But then in our case, the life cycle of musical instrument is not being managed by musician. It's managing itself. So that means the musical instrument, which is true, the musical instrument can exist without the existence of the musician. You don't have, and the musician can also exist without the existence of a musical instrument. So there's no life cycle dependency here. They can exist without the existence of the other. So, and remember, the musician is a person. So you're telling me as a person, in order for you to exist, you need a musical instrument to exist first, which is false. Yeah, in order for them, yeah, just keep that difference in mind. But they did tell you, you don't have to think about it too much and be like, okay, is it aggregation? Is it composition? You look at here, does it maintain the life cycle? If it does maintain the life cycle, then it's composition. If it does not maintain the life cycle, then it's aggregation. Then aggregation means that they don't depend on each other's existence in order to exist. So keep that in mind. And then now I'm going to export the design. And then I'm going to choose the, what's that one? SVG, Cairo Scalable Vector Graphics. This extension, it maintains quality even when you try to, when you zoom the image, when you zoom into the image. So that's why I choose that one. Then I'm gonna save it on my desktop so it's easier to find. Then I'm gonna open Microsoft Word. And then yeah, we're just gonna use Microsoft Word to generate the answers. And then to create the memo basically. And then I go to my device, I insert the image. That's the nice thing about SVG. Even after zooming in, you see it maintains you can read, you see, I can zoom in as many times as I want, but it won't lose quality. It maintains the quality. That's the nice thing about SVG. Yeah, that should be fine. Yeah, that's it. That should be fine. So, okay, let me do this. Let me give it a heading so that you can know. Computer Science 1B 2022 exam memo, right? And then this was question 1.1. Yeah, we should. Yeah, I want you to be able to follow what's going on here instead of just looking at the memo and like, okay, which question was it again? Which question was he answering here? I don't want you to end up having to guess. And then 1.2. Now we're going to 1.2. So now I don't need this one. I don't need D anymore. Exit without save because I already saved it. Yeah, so this is our diagram. It should be like this. And then I'll just open Notepad if I need it again. So let's see. Let's do 1.2 now. A dash can be used to store data that is not associated with functionality. That's very simple. It's a record structure. So what does that mean when you say it's not associated with functionality? Listen, try to pick up on these things because these people are trying by all means to give you a hint. Look at this word functionality. What part makes it confusing? It's LET. So remove LET. What are you left with? Function. So they're saying here a dash can be used to store data without functions. So what mechanism can you use to store data? Only data without functions. It's a record structure. Because with the class, right? Remember the class you store both. You store both data and functions. With the record structure, you only store data. So if you remember that what is what we talked about record structures and classes. So a record structure, right, is mainly for data, only data. So for example, you want to create a student. Okay, usually they say, but don't worry about this. But yeah, I was reading this other document, and they said you should normalize naming. I don't know. They said you should normalize what naming your record structures in uppercase so that you don't confuse the data types inside C++ with this one. But you can just capitalize the first letter like this. That should be fine. Yeah, it's still fine. So struct, right? So you can use this record structure to create the type student. So all I'm saying in this one line, in these three lines, right? All I'm saying is that this is what I'm remember when you're writing code, you're communicating with the computer. So in these three lines, what this means, it means create a data type for me, and I want it to be named student. That's what you're telling the computer. The data type should be named student. And this data type only works with data because you've used the struct keyword. So it knows, oh, you only want to work with data, you don't want functions. Then it's like, okay, I understand, I'll do that for you. Remember that in a way, the computer's like your servant. If you don't give it correct instructions, it's gonna malfunction, it's gonna do things that you didn't expect it to do. But at the end of the day, you are the one to blame because you didn't give it clear instructions. So you must understand the instructions, which one instructs it to do this, which one instructs it to do that. Know the difference. So if you only want to define data, use the keyword struct. You create a record structure. But if you want data, if you want a data type of which it's going to be coupled or it's going to be grouped with functions, then you should use the class keyword. So you're going to say class and then student. So now what happens is that now this is how it's going to translate class. So it's going to say create a data type for me, and I want it to be named student. And this data type works with data and operations. Basically, it works with variables. Remember, data is just variables. We use variables to keep track of data, and operations is just functions. So all you're saying is that create a data type for me, and I want it to be named student. And it should work with data. Basically, it should work with variables and operations and functions. So it should work with both functions and variables. With this record structure, should only have variables. So that's why yeah, you should just know there's two differences. I'm not gonna go into the nitty and gritty, try to explain extra information, but yeah, this is only the information you need to know. Record structure stores data, only variables. Class stores data and operations, variables and functions. So the answer is going to be C, record structure, because they said can be used with data that does not have functionality. So there's no functions. So 1.2, the answer is going to be C. And then 1.3, okay, let me remove this. Then 1.3, assume Q1 class has a source object. Okay, this is what they mean. So as soon as you start reading that statement, try to picture it. So they assume class Q1, they're saying it has a source object. So I'm gonna go here, then make it okay. Let's use something that's gonna highlight this thing properly, C++ code properly. So let's do that. Yeah, like this. So what they're saying is that create a class. We mentioned there's a class called Q1, right? And it has a source object. So source like this, and then we're gonna call it underscore source. We don't have to worry about lifecycle management, whatever. We were not told that information yet. Remember what we've read so far. We've only read up to here. We haven't read the rest of the statement. So let's read. When Q1 is instantiated or destroyed, the source is also created or destroyed. That means there's lifecycle dependency. What do they mean when it's also created and destroyed? They mean this when you go to when you open q1.cpp. Remember that with lifecycle dependency, how do you manage the lifecycle? You do like this. You'd have q1, that's the class, and then you have that default constructor or whatever. And then at the end of the day, so you'd have some code for Q1, right? To initialize the rows and columns and whatnot, all of those things. And then at the end of the day, you'd come here and you say source is equals to new source, right? That's life cycle management. Life cycle management. And then when you get to the destructor, okay, it's Q1, colon, and then destructor Q1. And then you'd write some code for Q1, right? And then at the end of the day, you delete underscore source, and then also set it to a null pointer. You do that at the end of the day, right? So that's what they mean by that statement. They mean whenever you allocated Q1, you also allocated memory for object, which means that there's life cycle dependency, because the only time we do that is because we only do that if we have a pointer, and that pointer signifies or denotes that we have life cycle dependence. And they also say that when you deallocate your Q1, you also deallocate memory for the source, of which that's lifecycle management. So now we know there's lifecycle management. And as you can see, if you understand this thing, you won't take time answering question one. If you really understand what's going on, don't take time. Look at this question, and we did talk about it. What kind of relationship is this? Remember when I said there's lifecycle management, there is composition. There's there's life cycle dependency. So that's composition. If there is no life cycle management, that's aggregation. Remember, I talked about it here. When it says the musician does not maintain the life cycle of musical instruments, we talked about it there. That was aggregation, right? But look at here, it's being managed. So it's composition. Remember, all the other ones are just there to throw you off, to confuse you. So if you don't know, you're gonna be confused. You're gonna allow yourself to be confused. I'm like, Mara, it could be inheritance. It could be polymorph. No, you're totally off topic. It's only these two options that apply. And depending on what you have been told, one is more applicable than other. I mean, these people are very lenient. I think you got a half mark if you wrote aggregation because you're halfway there, because you actually you clearly understand what's going on. You're not like these ones who chose these three options. They're way off. But if you chose composition, it's a full mark because you are you are you you got the exact answer that they're looking for. You clearly understand what's going on. So it's going to be composition because we are managing the object. We are allocating and deallocating the object. So the answer is going to be A. And then 1.4, assume that the class Q1 has a static. You see, when they say assume, to start declare those things. And they say it is a static data member, right? Declare them, start creating them. So remember, we're done. We are no longer dealing with this question about source. So I just remove source. They said it has a static member, right? So static, remember, we have to make them public. So static, const, or static, I don't know. But yeah, it has to be const. And the data type here, we don't know for now. We just leave it there. And then it's called the default underscore value, right? And since we don't know the type, we don't know what to initialize it to. We haven't read that. We haven't read anything that talks about what type it is. So they just said it's a data member that's called default. It's a static one, meaning that it's basically they're telling you that it's a constant in a way, because you only use, most of the time, you use static only when you're creating constants. So default value can exist even if an object of Q1 does not exist. Oh yeah, they're asking you, basically what they're asking you is that, can you access, when they talk about, when they use static, just know when they use the keyword static and then they talk about can it exist, and they talk about existence. All they're saying is that, can you access? Can you say, imagine this is your main.cpp. In your main.cpp, can you go like can you access default value like this without creating an instance of Q1? So object, it's gonna say obj Q1 like this. Yeah. So can you access this default value without creating the object? True or false? It's true. You can access. Remember that when you have a static member variable, right? When you have a static member variable, I'm just going to demonstrate now that it's 100% true. So you could you you can access without the existence of that one. So I'm just going to open this one that I was using, solution that I was working on here. Okay, so okay. Okay, I'm not going to create the header file and CSV file. That's going to waste time. So let's create class Q1. So there's Q1, right? And then remember what they said. It's a static member variable, right? So we're just going to, let's just assume, let's give it any type. Remember, they don't care about the type. The type doesn't really matter in this case. In this case, you don't need the data type to answer the question. So I'm just going to make it an int for the sake of simplicity. So int like this is equals to 100, right? So it's true, 100% true. Static means, you know what static means? Static basically means that each class is going to have one copy, or each instance of this class is going to have one copy. In other terms, it means that this variable, it's tied to the class and not tied to the object. So meaning that in order for me to use this, I don't need the object. I don't need it. The fact that there's the static keyword, I don't need to have an instance of Q1 to use default value. So how would I use it? So it's simple. You use it the normal way. You'd say the name of the class Q1 like this, colon, followed by that static member variable, default value, and then you say end line. That's how you'd access it. So you see, I didn't create, did you see me create an instance of Q1? No, I didn't. So it's a static, meaning that there's one copy, everyone is sharing it. So that means it's actually tied to the class. I don't need a instance to be able to use it. You see, there's the 100. I did get the value. But did I create an instance? No, I didn't. Remember what static means. Imagine we have something like a piggy bank to save money, right? So I have a piggy bank to save money. So what static does, right? It's like, imagine you and a friend, you had the exact same piggy bank, same colors, you bought it for the same price from the same store, everything is exactly the same. So as you can see, you guys have actually wasted money because you bought the exact same thing. So what static does, it's like, okay, instead of us using two piggy banks to store the money, let's buy one and then we share that piggy bank. So we share that piggy bank. I'm gonna put my money and you also to put your own money in there. We're gonna share it. So that's what static does. So and another advantage of using static is that since since it's not like dependent on the creation of an instance of Q1 of that class, it means that it doesn't each remember when you create an instance, right? An instance basically it's like saying that information is different. Each one has their own copy. That's what instance does. Each person has their own copy. That's what instance does. As you can see, I can demonstrate it right now. Let's create an integer, call it x. It goes to 0, right? I just initialize it to 0. Mind you, I'm making it public because I don't want to waste time creating accessors. You shouldn't do that. This is just for demonstration purposes. So Q1, I'm gonna have excuse me, I'm gonna have object 1, and then I'm gonna have Q1, and then I'm gonna have object 2. Right, I have 2 objects. And then the first object, right, object 1.x, remember it's public, I'm gonna set it to 90. And then objects 2's value, x value, I'm gonna set it to 34, right? So these values need to be different. So we're gonna say object 1's value. What's the object 1's value? obj1.x. And then new line character, then cout object 2's value dot x and line. As you can see, the values are going to be different because each instance is going to get its own copy. It's going to work with its own copy. As you can see, object 1 is the value of 90, object 2 is the value of 234. So what static means, it means that let's not make it depend on an instance. So let's not make them have their own copy. They're going to share. It's actually part of the class, not part of the instance or the object. As you can see, I'm using the class to access it. It's not part of the object. It's just part of that class, Q1. Q1 in this instance. Just keep that in mind. So the answer is true here. That's exactly how it is. A static data member variable, it exists without you creating an instance of that class. So it's true. So I think it's A, if I'm not mistaken. Okay, you don't say A, you have to say true or false. So it's true. And then 1.5. So 1.5, let's see 1.5. Assume that the Q1 class has a data member function that must be overridden by a derived class. Yeah, they're using terminology to try and confuse you, but if you listen, you realize, okay, I'm not confused. I understand what's going on. So they're saying assume that this class is a function, right? So when I call it, let's just use a toString function. Imagine there's a toString function because it didn't say which function what does it do. They just said imagine there's a function that must be overridden. So this function must be overridden, right? So remember remember the keyword virtual. So virtual basically it's just that's the keyword they chose in C++, but if you check in other classes, they actually use the keyword override. So what basically means, what virtual means, right? It means that this function is overridable. So you can override it. So you can override it, or you can override, meaning that if this function had previously had information inside of the base class or implementation in the base class, I can replace all of that information with my own unique information. That's what override virtual means or overridable means. It means you're overriding it. So whatever that base class has, I'm going to override it and put my own information. But we don't write, there's no keyword code overridable in C++. It's not there. So instead we use the keyword virtual. So basically what virtual means, in other words, it means overridable. You can override it. So you can make it a pure virtual or just a virtual function. So a virtual function, it could be, so if you don't, let's say you don't make it a pure virtual, it means that some classes or some child classes or some children of this base class will not implement it. So they'll just take the base class's implementation. So this is the first approach. I could just leave it like this because some classes will want the base class's implementation. Some won't, and then those who won't want the base class's implementation, they can just override it. Or you can just say every instance needs to override by putting the equals to 0. That means it's now pure virtual. That means it doesn't return anything. There's no implementation. So since there's no implementation, every child class is forced to implement it. So those are the two ways. We have just a virtual function and a pure virtual function. Pure virtual function, meaning that every child class needs to provide code, or else it won't compile. That's pure virtual. If it's just virtual, it means that you can or cannot. It's not mandatory, it's optional to override it. It's optional. But then you put the equals to 0, it's now pure virtual. That means it's non-optional, it's non-negotiable. You have to override this function. All those child classes that inherit from this, they have to override it. So just know that difference. So virtual means override. So they're saying that class contains an overridden must or contains a mem function that must be overridden. So basically overridden means that a function must be, you must override that function. If you inherit from that class, you must override it. That's what it means. So that means it's virtual. So the keyword that we're looking for here is virtual. So it's going to be E, virtual. So E, virtual. And then 1.6, we're almost there, done with question 1. The constructors of a class all have the same name, right? Yeah, they do, but different sets of parameters. So they have a different set of parameters. Basically, what they're saying is that we can have, okay, let me just put back Q1. So Q1 can have different constructors, right? There's the parameterless, there's the parameterized, takes in some integer, and then you can have Q1, which takes in some Q1 reference. So as you can see, the set of parameters is different. Here I'm taking an integer, here I take in an integer, and then here I'm taking in a Q1 reference, or a reference to Q1. Here I'm taking in no parameters. So with this approach, right, of having especially a function or a constructor. Okay, yeah, let's start with constructors. When you have constructors like this, you see that they have the exact same name, right? But then the thing that's different is the parameters. And by parameters, we are saying the data type or the signature of it. Maybe on this one, you're taking no type, this one, you're taking an integer. Here, you're taking Q1. You see, the parameters are different. So since these are constructors, we call this approach of having the same name, having different constructors, but they have different parameters. We call this approach constructor overloading. So that's what it's called, having different constructors like this, and then they take in different types of parameters. That's called constructor overloading, and it's allowed. And when you can also do the same thing with functions. But then since now you'll be dealing with functions, to do that, we then now call it function overloading, because we're overloading functions. Since here there's constructors, we're overloading constructors. So basically what overload, what this means is basically what you're seeing here. Having the function with the same name, but different parameters. So for example, I can come here and have, let's call it, let me see, what can I call it? I don't want to be too complicated. Void enter, right? And then I can have another exact same signature, but then this one takes in an integer. And then I can have an exact same one, but then this one takes in a double. And then I can have the exact same one, but then takes in a character. I can have an exact same one that takes in a Q1 reference. I can have all of that. And it's allowed. If you try to build it, it won't give you any issues, because what I'm doing here, it's called function overloading, because these are functions. And the only thing that's different is the signature. Look at the parameters. This one takes in no parameter. This one takes in only an integer. This one takes in only a double. So this parameter double is not the same as int. This one is the same as, this is Q1. It's not the same as double. It's not the same as int. So overloading, now let's see the concept of overloading. So now, depending on which function, how does it know which function you've called? It depends on the parameter you've passed, the data type of the parameter. So I'm gonna say dot enter, you see, it's the exact same names. And then I do this, right? If I leave it empty like this, I'm basically telling it to call this version. If I pass in an integer 90, I'm telling it to use that implementation for the one that takes in an integer. And then if I tell it to take 9.0, that's a double. So it's going to use this version. If I tell it to take in obj1, an object of Q1 or an instance of Q1, it's going to use this one. So that's method of overloading. We also have constructor overloading, and we've been doing it the whole time. Because remember, constructors have the same thing. Now, what is this concept referred to? Remember what we talked about? It's called overloading. So there's the overloading. So 1.6 is going to be A. And then 1.7, 1.7. Okay, let's see 1.7. Write your answers to the following. Consider this following code segment in main function. So imagine this is inside your main function. So would you consider student an abstract data type? Provide a reason for your answer based on the definition of an abstract data type. So if you remember what an abstract data type is, an abstract data type is this. This is an abstract data type. Definition, abstract data type. Definition, right? The logical properties are kept separate from the implementation details. So what does this definition mean? This definition means that the class that you the class that you the data type that you have, it's abstract in the sense that if you see only the one file, you don't know exactly how it's implemented, right? Or basically you can view this as like there's a header file and .cpp file, right? The logical properties are inside the header file. So it's like the planning part, how it should look. And remember, when you look at the header file, you don't know how it's implemented, right? You have no clue. You'd have to see the .cpp file in order for you to see how it's implemented. So would I consider student as an abstract data type? Yes. Look at the code. I don't know how this is implemented. I don't know marks. Is it allocated? How is it allocated? I don't know any of that information. So since I don't know any of that information, this is definitely an abstract data type. So 1.7, I'm gonna say yes. Why? This could be one of the reasons, right? So the first reason, you can just say the logical properties are kept separate from the implementation details. You can write it like this. Or you can say in simple English, you can say information about how the student class is implemented is not given. Is not given or shown. So they didn't show you the information of how it's implemented. So it is abstract. It's an abstract data type. So it is abstract. So that's all you had to write there. 3 marks. 1 mark for yes or no, depending on the answer that they expected. They expected the answer yes. So if you wrote no, obviously the no is gonna be wrong and your reasoning is gonna be wrong because your supporting statement supports an incorrect answer. Your friend recently read about abstract-based classes, right? Explain the following concepts to your friend. What makes a class abstract? So basically, what's an abstract class? So remember the virtual function that we're talking about. Virtual meaning that it can be overridable. It is overridable. In other words, it's an overridable function, right? But in other words, this function here, we call it an abstract function. It's an abstract function. It's abstract. So basically, there's nothing. There's no implementation. It's abstract. You don't know what it does. There's nothing that tells you what it does. There's no implementation for it. It's an abstract function. So obviously, if I'm Q1 and I have an abstract function, obviously this will make me an abstract class. So that will make me an abstract class because I have an abstract function. Basically, I have a virtual function. That makes me abstract. I have a pure virtual function. Yeah, it should be pure virtual, not just virtual. It should be pure virtual, because remember with virtual, I should write implementation in my class, my base class, and then other classes can or cannot inherit. They can decide. but there's going to be code for that function. That means this class is going to be complete. Abstract, just don't be shocked by these words. Abstract basically means that it's incomplete. That's what abstract means. So what's the abstract function? It's an incomplete function. It's not complete. As you can see, we're saying it's equals to 0. There's no code for it. It's not complete. It's incomplete, basically. So since I have an incomplete function, this makes this class abstract or incomplete. So you'd have to have a pure virtual function in order for it to be abstract. So now you need to explain. Answer the question, what makes the class abstract? When the class, you should write it in full, the class becomes abstract when it has, or for some people like fancy English, when it contains a pure, remember there's a difference between virtual and pure. The virtual function, the base class has its own implementation, and child classes can choose whether they want to override it or not. But a pure virtual, they are forced to. So that means that function has no implementation, which means that that function is abstract. And abstract, we said, it means it's incomplete. And if you have a class that is something that's incomplete, it means the class the class itself is incomplete. So I'm going to have a pure virtual function. So a class becomes abstract when it contains or has a pure virtual function. Simple. You don't have to explain any extra things. Why an abstract class cannot be instantiated? Why can it not be instantiated? Here you can play around with English here. You can put it in your own words. But in simple terms, the class is incomplete. The class is incomplete as it's abstract. So just instead of using the word abstract to answer the abstract, remember they're saying why is an abstract class, why an abstract class cannot be instantiated. You can't say because it's an abstract class. Yeah, you can't do that. Just use a different terminology for it. Just say it's incomplete. And because the class, okay, I should say the class cannot be instantiated because it is incomplete. It is incomplete. So you could go into details and explain and say, for example, it's like trying to say tenants can move in, but the building doesn't have, some floors are missing in the building. Obviously, that building can fall at any second. If there's floors missing or there's windows missing, they didn't finish putting the windows and whatnot, obviously that's an incomplete thing. That's an abstract building. That's an incomplete building. It's not done yet. It's not fit for people to use it. So therefore, you cannot instantiate it and say, okay, others can use this object because it's incomplete. Some code is missing. So let's see. Describe, let's say, okay, we'll get to this question later when you get to that topic. I don't want to mix things. I want to go through things that you guys have done so far and you are well knowledgeable of. So let's see. Name the object-oriented composition, object-oriented concept. So we'll get to 1.9 later. So let's see. What's going to be the answer for I? What's the object-oriented concept? So remember, it's containment. So one thing is contained within another thing. So a person has a pen. I don't need to exist in order for the pen to be there. Yeah, I don't have to exist in order for the pen to be there. Think about it. The person doesn't exist just because let me see. A person has a pen. Yeah, I don't have to exist in order for the pen to exist. Me, myself, the person who has the pen, I don't have to exist. So I would say here it's gonna be aggregation. I don't have to exist. I mean, if you think about it in a more deeper sense, you could technically say I have to exist. because those pens are made by people. But yeah, I understand, but don't get too philosophical on it. Just keep it in simple terms. Does the person who owns the pen need to exist in order for the pen to exist? No, definitely not. So this is going to be aggregation. Aggregation. Then number two, name the object-oriented concept. A person has emotions. So obvious emotions cannot exist without the person because the emotions are a part of the person. We cannot all exist and emotions exist. Makes no sense. So that's definitely composition. So composition. And then a person paints a wall. What is it called? There's this, I forgot the term for it, but remember that we have aggregation, composition, inheritance. I think is it generalization? I don't know. I think it's generalization, something like that, if I'm not mistaken. Yeah, I think it's generalized. I forgot the right term for it. But I think the answer could be it's generalization. Yeah, I think it's generalization. I would have to confirm. Yeah, I'd have to confirm generalization because it's neither composition, no aggregation, no inheritance. It's none of those things. So it's just generalization. So yeah, that's it for the session. Yeah, we just did question one. Then the next session I'll start from 1 point. Okay, we won't touch 1.9. We'll get to it when you're doing the topic. So we'll just continue with our code. Question two. Let me see question two. Okay, yeah, I see it. And then write code to protect the following using exception handling, assuming that the class has been updated to raise exceptions, blah, blah, blah. Okay, we have this reading from the file, alignment padding, assume that water levels the dead, write code that accesses the deb by index, blah, blah, blah. And then DLL. Okay. Yeah, it's not too bad, but yeah, that's it for now. See you in the next session.